Yes, Ahmed, why are you late in today's class?
Sorry, sir. I
Okay, okay.
meeting I didn't come, sir.
Okay, no, meeting was not cancelled.
Oh, okay,
Okay,
sir.
so we were just discussing what we revised in the previous, what we discussed in the previous class. We were just revising it. Okay, as you were present in the previous class. So types of combustion. There are two types of combustion. There are
Yes,
some
sir.
substances that in a very short span of time uh, it will give off a good amount of heat and light. So when you burn LPG gas, does it take time to burn?
No.
No. Whenever you light a stove, whenever you light LPG gas, it burns off immediately and gives off heat and light. Okay.
Yes, sir.
So those substance in that cases, there is a rapid combustion. The fuel immediately catches fire. And then you have some examples in which the fuel to burn the fuel, you do not provide it with heat. Okay, it catches fire on its own. Like there are many cases of forest fire in Brazil and in Australia and in different parts of the world. Every year, due to excessive heat, there is forest fire, and so many wildlife and forest resources lost. So why does it happen? Because in the summer season, the branches and the stems of the plant, they go dry. Okay, the leaves fell off, so there is complete dryness in them. Okay, and when wind flows across them, the branches of the plants rubs against each other. Due to rubbing, heat is produced, friction is produced. Obviously, friction will lead to production of heat. Okay, so on their own they catches fire due to production of heat. So what happens? They catches fire spontaneously on their own. So hence such type of combustion is called spontaneous combustion. For example, forest fire. Right. Okay. So here you will see, even in your environment, even in your surrounding, you might have observed in rare cases, if the temperature exceeds 40 degree, 42 degree, 45 degree, the temperature is reaches up to 42 or 45 degree. There are some substances that can catch fire. Suppose you have an electric equipment. Okay. So in most of the cases, when the temperature reaches close to 50 degrees Celsius, many electric equipments can catch fire, right?
Yes, sir.
Or
Yes, sir.
let's say there's a wire in which electricity is flowing. So you guys must have studied about short circuit. Like there are two wires in which electricity is flowing. Okay, and at some point of time, at some stage, the two wires joined here. The two wires joined, and electricity started to flow in the same wire. Earlier, the electricity that was flowing in two different wires, now it's flowing the same wire. Let's call it wire one, wire two. Now the two wires joined, and the electricity is flowing in the same wire. Look, the diagram is supposed to be looking like this. So there are not two wires here, wire one and wire two here. Suppose what happened from here, the wire started to melt. Okay, now what happened? This wire, after melting, it came in contact with this wire. Came in contact with this wire. Let's name them wire A and wire B. Wire A, after melting from here, it came in contact with wire B. And when it came in contact with wire B, okay, basically we are talking about the internal copper of, if the it's copper wire, we are talking about the copper. Now the electricity, let's say 15 ampere of electric current was flowing from it, and 15 ampere of electric current was flowing from it. Now from the same wire, when they came in contact, 13 ampere of current will flow from it, right guys? But the capacity of this wire was only to be able to carry 15 ampere of current. I'm just taking an example here. Ampere is now the unit of current. Okay guys, ampere is the unit of current. So now 30 ampere of current is flowing from the same wire, but the capacity of the wire was to carry only 15 ampere. So hence the wire will catch fire due to overheating. So there's a spontaneous combustion here as well, right? Ahmed and Arhan.
Yes, sir. Yes, sir.
Yes, sir, but how does the wire connect itself in one?
Yeah, that's a good question. That may happen because if, let's say, if the surrounding temperature reaches, if the surrounding temperature increases, in that case, okay, or if there's too much crowding in the wire, okay, if the wiring is not proper, in that case also the wires, if let's say that there's too congestion in the wire, okay, and there's some problem in a wire, let's one of the wire is of either poor quality, okay, or let's say the rubber of the wire, the envelope basically in which wires have a rubber coating, right? So the rubber coating might be of poor quality, okay. So due to these reasons, the wires may come into contact. If the surrounding temperature is too much, the surrounding temperature it exceeds, and if the rubber coating is of poor quality and it starts to melt after a period of time, then the wires may come into contact. So forest fires and short circuit, these are some examples of spontaneous combustion. Okay, then we have concept of fuel. So fuel, what is fuel? Fuel is any substance that burns off readily. Any substance that burns off to give us heat and light, that will be simply called as fuel. And fuel can be of three different forms. It could be in liquid, solid, and gaseous. Right, guys? Give me two
Yes,
examples
sir.
of solid fuel.
Sir, coal and
Yes, sir. Can you?
Two examples of solid fuel.
sir, coal and fossil fuels.
Petroleum. Coal.
I'm asking about solid fuel.
Solid fuel. Okay.
Sir, does fossil fuels count?
Sir, coal.
Coal, no, in fossil fuel, no, there will be liquid, solid, and gaseous fuel as well. I'm asking about solid fuel.
Yes, sir.
Solid,
Coal
yeah, coal
and petroleum.
is petrol in solid form.
Yes,
Ahmed,
sir. Petroleum solid. Petroleum liquid.
The
petroleum
charcoal?
is in liquid state. Charcoal, very good. Yeah, give two examples of liquid fuel as well. It could be more than two.
The petroleum, the petroleum and kerosene.
Petrol, kerosene, right? And Ahmed, give example of gaseous fuel.
Okay, sir. Natural gas.
Okay, natural gas,
Sir, is LPG,
LPG,
CNG.
CNG, that is simply the natural gas in compressed form.
Yes.
And you have biogas also coming from the biogas plants, right?
Oh, okay.
Yes, liquid nitrogen is used. Did you say nitrogen?
No, sir.
Okay, liquid nitrogen is also used. Okay, now what do we mean by ideal fuel? So Ahmed, you tell me, we discussed this thing in the previous class.
Yes,
Yeah,
sir.
you tell me what is an ideal fuel.
The fuel that has all four categories, sir.
Yeah, what were those categories or
Uh,
features?
it should be non-harmful.
Yes, it should not release toxic gases on burning.
Yes, and sir, and
So it should be smokeless.
Yeah, that will be coming under toxic gases, and yeah, you can include that as well. A fuel that does not release toxic gases, okay, is smokeless, or it is cheap, readily
yes,
available.
yes,
Re- Readily available means available in good amount in nature. Readily available, okay. Easy to transport, easy to transport. Suitable ignition temperature. Ahmed, we talked
yes.
about ignition temperature also.
Ignition temperature. Oh,
Arhan, do you have any idea of this one? Ignition temperature? Look,
It's just the
yeah,
amount of temperature on ignition.
the amount of temperature required to ignite. Exactly. Exactly. Ahmed, do you
yes, sir.
revise after the classes or not, Ahmed?
I do revise.
Yeah.
It's been times that we haven't it since it's been like
Yeah. We hadn't,
so,
we are having science class after quite a while. Okay.
yes,
So different substances have different temperatures at which they catch fire. For example, a LPG gas, or for example, and wood, they will catch fire at different temperature. So different substances have different temperature to catch fire. So that is called ignition temperature, right? So the thing is now, the fuel, an ideal fuel should have a suitable ignition temperature, neither too high, neither too low. Okay. High calorific value, high calorific value means the amount of heat given off from the fuel should be good. Okay. But the thing is, the reality is, in nature, there is no ideal fuel existing. Like, you won't find any fuel that does not causes pollution, that is easy to transport, or that is easily available in the nature, that is that has a suitable ignition temperature, or that has a high calorific value, or that is cheap. All these features cannot be found in a single type of fuel, right?
yes, sir.
So that is the case. Anand, did you got this one or not?
Yes.
Okay. So this ignition temperature was basically, we can say, it was the lowest temperature at which a substance catches fire and it starts burning. So that was the ignition temperature. Okay. Now comes the calorific value and efficiency of a fuel. So the thing, so what does this calorific value means? The amount of heat energy produced on the complete combustion of 1 kg of a fuel, that will be called as calorific value. So suppose I give you a bag containing 1 kg coal, okay, and you have got a cylinder that has 1 kg of LPG gas in it. All right, guys. So do tell me which fuel is going to give you guys more amount of heat.
Sir, LPG.
LPG, obviously, isn't it, Ahmed?
Yes, it is.
So in this case, the calorific value of LPG is greater than coal, right? Since we had both of them in the same quantity. Okay, so it is a very suitable way of representing the amount of heat given off from the different fuels. Okay, so a fuel which has got a higher calorific value will be a more efficient fuel, right? Okay,
Yes,
and further,
Yes.
we talked about the burning of a matchstick. Okay, first let's talk about its history. So the history of the matchstick is very old, right? It is almost 5,000 years old, right? So 5,000 years old, small pieces of pine wood were dipped in sulfur. So back then also people had knowledge about sulfur. Sulfur is a combustible substance and has got a very unpleasant smell as well. So they had pine wood, and they used to dip that pine wood in paste of sulfur, right? Okay. So small pieces of pine wood were dipped in sulfur, were used as matches in ancient Egypt. Now the modern safety matches was developed only about 200 years ago. The modern matchsticks which we use were developed around 200 years ago only. But the history dates back to 5,000 years old, where in the ancient Egypt it was used. Okay, so mainly it was used for artillery. Artillery means as a weapon. Okay, right. Even the history of candle also dates back to almost 4 5,000 years old. Right, guys?
Yes, sir.
Do research about this. Okay, how old is this candle which we are using? Even in the so many villages, you will see people still have got like you see many of the people have occupation that goes on generation after generation after generation, like the craft of hand looming. Okay, people take it after generation, people transfer it to their kids, then they transfer it to their kids, and so on. There are so many occupations that gets transferred from one generation to another. So the art of candle making, or the art of hand looming, okay, or the art of leather crafting, leather making, these are some professions which are transferred from generation after generation, right, guys? Okay,
Yes,
so what happened now? A mixture of antimony trisulfide, potassium chlorate, these are some chemical components you guys will study in future classes. So a mixture of antimony trisulfate and a potassium chlorate. What were they? Antimony trisulfate plus potassium chlorate. Potassium chlorate. Okay. KClO4, that is it. Okay. Plus white phosphorus. White phosphorus was also added. Okay. Phosphorus comes in various colors. It also comes in white color also. So white phosphorus and some glue with and starch was applied on the head of match made of suitable wood. So some glue was also taken, right, guys? Plus starch was also taken. We can add starch also. So when they had traditional method of making matchsticks, these were the components taken and a mixture was made out of them, and it was applied on the head of the matchstick, right, guys?
excuse me, sir.
Yeah.
Does the color affect the phosphorus?
Burning. Does the color?
Affect the phosphorus मतलब, properties?
No, are you talking about this white phosphorus?
Yes, sir. As you mentioned that phosphorus comes in various colors.
No. Actually, the thing is not. It does not have to do with the color. It has to do with the chemical property of the substance which we are using, right? So this white phosphorus helps in combustion. That's why it was taken. Okay. So if you have yellow phosphorus or any phosphorus of different color, it would not have help in combustion. Okay. So it has more to do
Okay.
with the property, right, guys?
Okay.
So these were taken, it was mixed in a glue, and starch was also added in it. So this mixture was applied on the head of a pine stick, and then your matchsticks was ready. And when it was struck against a rough surface, white phosphorus got ignited due to the heat of friction. So you see, as I told you, this white phosphorus, it basically this is the component that gets ignited. So when this matchstick, or let's call it a traditional matchstick. Traditional means something which is old. So traditional matchstick, when it was roughed against some rough surface, right, guys? So what happened? The white phosphorus present on the head of this matchstick, it got ignited, and then all other components also caught fire, right, guys? So
Yes, sir.
if we were to rub a simple pine stick or any another suitable stick on a rough surface, it would not have caught fire. Although there would have been some friction in between this wood and the rough surface, but it would not have caught fire because the heat produced was not enough. But now I have applied a mixture of these components on its head. Upon a slight friction, the white phosphorus will immediately caught fire, and hence the minimum temperature required for burning this wood will be achieved, and hence matchstick will caught fire. Did you guys got this one or not?
So, sir, phosphorus is an important part of
Exactly.
making fine stick ignite.
Exactly. It was a very important part, right?
Okay.
Okay. So this started the combustion of match. However, this white phosphorus has some disadvantages. This white phosphorus had some disadvantages. Like what? It has started causing complications in the health of the workers who were manufacturing matchsticks. Right, guys? So both it proved dangerous both for the workers involved in the manufacturing of matches and for the users of the matchstick as well, because it gave off harmful gases. When it was burned, it released harmful gases. Even now, if you burn a matchstick and if your nose is clear to the matchstick, I mean the gas that comes out when you burn the matchsticks, that gas is not suitable. So you need to light a matchstick at a distance and try not to inhale the smoke coming out of it. Right, guys? So
Yes, sir.
these days, safety matches contains only antimony trisulfate. What does it contain only? It contains only antimony trisulfate, and it contains antimony, and it contains only potassium chlorate. Right, guys?
Okay, sir.
Look, only these components are found nowadays in the matchsticks. And what else is added?
The
Yeah,
glue.
no glue. Yeah, glue is added to stick them. Right, these three components are nowadays added only. Okay. And the rough surface, if you see the sideways of the matchsticks, it
Glass,
contains what? It contains
glass.
powdered form of glass. Very good. Okay. So let's say this is the sideways of a matchstick here. This is what? This is glass powder. Right, guys?
Yes, sir.
So these days, the head of the safety contains only antimony trisulfate and potassium chloride. The rubbing surface has powdered glass and a little red phosphorus in it. Now, see here. This consists of red phosphorus. As I told you guys, phosphorus comes in various colors. So there's a red phosphorus also. So this red phosphorus does the work of ignition here. Right, guys? Okay. So when the match is
Yes.
struck against the rubbing surface, some red phosphorus gets converted into white phosphorus. Now look, here's an interesting part. This red phosphorus, which is present on the match box, it gets converted into what?
White phosphorus.
White phosphorus. It is now converting into white phosphorus. Okay, so you have the matchstick, you rubbed it against the matchbox. Now the red phosphorus present on the matchbox, now it got converted into white phosphorus. Now this white phosphorus was slightly less dangerous. Okay, now when the match is struck against the rubbing surface, some of the red phosphorus got converted into white phosphorus. This immediately reacts with potassium chlorate in the matchstick head to produce enough heat. Okay, so this white phosphorus, it generates enough heat for potassium chlorate to catch fire. As I told you, different substances in nature have got different ignition temperature. So this white phosphorus, now it produced enough heat for potassium chloride to catch fire, and hence the matchstick got lighted. Now, do you guys tell me, did you guys got this thing or not? The working of the matchsticks.
Yes, sir, I got.
Ahmed, you?
Yes, sir.
Yeah. In fact, we discussed this in the previous class as well, right?
Yes, sir. We did.
Yeah. So that is the case here. Now let's quickly move ahead. Ignition temperature. Okay, so that this is the topic common for both of you guys. Okay, common, I mean new for both of you guys. So what is ignition temperature? The lowest temperature at which a combustible substance catches fire when heated in air is called its ignition temperature. Okay, say this activity and one of you read this one. Ahmed, you read this one.
Sure, sir. Make 2 cups by folding a sheet of paper. Pour about 50 ml of water in one of the cups. Heat both the cups separately with a candle. What do you observe?
Yes. What do you guys think?
So,
Write your answers in the chat box. Like what just happened here. Just explain it in few words.
okay, sir.
Ahmed, is that your query or is that the answer? The
That's the answer.
paper. The paper. No. Your answers are not satisfactory here. Look here. See, in the first case here, in case 1 and case 2 here, what is the difference here? See, you have made a paper cup out of paper, and in the first case, you have put some water in the cup. And in the case 2, there is no water in the paper cup here. So what major difference we will observe here? What major difference you guys will observe here? See, in the first one, the heat, the paper which is being heated, it will transfer that heat to water, right, guys? So this heat is getting transferred to the water inside this paper cup. See this. This is the cup, right? And this is the flame here, and there is water in it. So the heat is getting transferred to the water here, and hence the ignition temperature of paper is being lowered here. Ignition temperature of paper is lowered. That's why the paper is not catching fire, because
Okay.
heat transferred from paper to water, right, guys? So that is
Yes.
the reason why the paper is not catching fire. While in the case 2 here, the paper is in direct contact with the fire, and it has nothing to which it will transfer the heat. So hence the paper too catches fire, right, guys? Okay, you guys got this one.
Okay,
Okay,
sir.
so that was the activity. Okay, inflammable substances, what are they?
Substances which are not flammable.
Yes, sir. The substances that do not catch fire.
That do not catch fire? No. Like many in many places you will have seen that precaution, and there is written inflammable substance. Inflammable.
So the substances which can catch fire easily.
Exactly.
And it
Okay.
is also a warning on flammable objects.
Exactly. Let's say if there's a cartoon, if there's a cartoon here. Okay. So in this, it will be a sign like this, and there will be fire sign. Okay, like this. So that will basically signify, denote here that some inflammable substances present inside this cartoon, and you need to be careful. So inflammable substances that can catch fire easily. Why is it so? Because they have low ignition temperature. Okay, so suppose there is a vehicle containing or carrying LPG, there will be a sign like that on the LPG vehicle. Or if the vehicle is carrying petrol, right guys? And in the petrol stations, there you will find this sign of inflammable substances. Be careful, there is inflammable substances. That's why person is not allowed to smoke cigarette when the person is in petrol stations or gas stations, right guys? Because if there's leakage of petrol, the whole, because you see petrol stations, wherever they are built, the whole underground, there is compartment built inside, just below the petrol station, and in that compartment petrol is stored, right? So even if a spark of that cigarette the person is smoking reaches this compartment, the whole building or the whole station is going to blow up, right guys? So that's why precaution needs to
Yes.
be taken. Now, how do we explain fire? So fire is basically the result of a chemical combustion reaction between the oxygen and some sort of fuel, right? So fire is basically the result of combustion. Okay, and how long this fire will last will depend upon the amount of fuel and amount of oxygen available, right guys?
Yes, sir.
Okay, that is simple thing about it. The important thing about is that with fire we need to be very careful, because fire can get out of control. Okay, if you increase the fuel, if you increase the air supply, and you are very irresponsible with fire, then it may be very fatal. Okay, so fire control. So fire can be controlled by removing the elements required for combustion, right, guys? So how do we control it? By,
So that putting sand.
yeah, by putting sand. Okay, but for all but for different types of fire we need to adopt different measures, right guys?
Yes, sir.
Okay, let's say if the fuel, if the cause of the fire is from electricity, in that case we cannot be using water, right? If the cause of the fire is some what do you say, is some petrol or oil, okay, any liquid fuel, in that case also we might not be using, in that case we will not be using water. I will explain why.
Yes, sir.
Okay, so for different causes of fire different measures needs to be taken. Okay, so any fire, okay, any fire needs three things to be present. Any fire needs three things to be present. It will need fuel, right guys? So we know what are the other two things a fire will need three things. First is fuel. Without fuel there will be no fire. Second is what?
Sir, oxygen.
Yes, oxygen. Ahmed, what is third? Miss Ahmed, are you there? Ran, what will be third?
The third one, sir.
Sir, the combustion level.
Yes,
The combustion
the combustion
level.
level. No, no, that is not the case. It's heat, source of heat. Fuel must be getting some source of heat, right? That's why it burned. Okay, so if any of these three things is removed, then the fire will stop and fire will be extinguished. So if you cut the supply of fuel, then the fire can be controlled. If you remove oxygen supply, then also fire can be controlled. And if you remove the source of heat also, or the basically you turn off, you basically turn down the heat, then also fire will stop. Right, guys? So first thing is by removing the fuel. What is fuel? It is basically the combustible substance. Second is what? By removing the heat. By removing the heat. That means by cooling. Okay. With what? By cooling with water. But not in all the cases. Okay. And the third is by cutting off air supply as well. By cutting off air supply. Right. For example, if a person has caught fire, we can simply wrap the person in blanket. Okay. But nowadays, let's say if a building has caught fire, now we will first the firefighters will look for the source of fire. Right. So depending upon the source of fire, different methods will be used. Most common of it is carbon dioxide. So carbon dioxide can be used to blow off the fire, no matter what has been the cause of fire. Right. So
Right,
let's
it's in fire extinguisher.
fire extinguishers. Exactly. Okay. Fire extinguishers. All right. So see this fire extinguisher. What does it? It is a device used by the fire brigade to control fire. Okay. What is its role? Its role is to cut off the supply of oxygen and to bring down the temperature of the fuel or both. So when we will come to that, we will discuss that one. Now let's study about each of them in detail. So by removing the fuel, what you are doing, you are basically removing the food for fire. Right, guys? Fuel is like a food for fire. So when fire starts in a room, all the combustible substances needs to be removed from that room, like the clothes, chair, tables, any substance that can catch fire. Right, guys? So see around yourself.
Yes.
So what are the combustible substances around yourself? So if a person is in a situation, if any person is in a situation where a fire has caught and it cannot be turned down immediately, then the person first needs to evacuate himself from there, or if there's a bigger danger and if it's possible, he needs to remove all the combustible substance. Okay, so basically these things are done by experts, firefighters, right, guys? So if possible, also one needs to remove cooking gas cylinder, right? Electricity should also be switched off. Okay. Or if let's say if the fire is near a pile of wood, okay, what you need to do, you need to remove the pile of wood from there as well, right? Okay, so that is how you remove the fuel. Next thing is removing the heat. So how do you remove the heat? First we discussed about fuel.
So what?
Now how do we remove the heat? Water.
So what?
Yeah. So water is generally used to remove the heat, right, guys? So if the burning
Yes, sir.
substances or the fuel for the source of or the fuel which has caught fire, if the source of the fire was, let's say, paper, clothes, or wood, then in that case water will be effective. Okay, so what will water do? Water will bring down the ignition temperature of the fuel. It will bring down the ignition temperature, right guys? So the fuel will no
Yes.
longer burn. Okay, but there are some limitations of use of water as well. So if the source, if the cause of fire is electricity, in that case you can no you cannot use water to turn off the fire. Why? Because generally the water which we use, the tap water, it is a a good conductor of electricity, right? So hence, if the person uses electricity, the person might caught electric shock. Okay, and also if the cause of fire is an oil fuel, a liquid fuel, right? If it is a petrol or diesel or kerosene oil, then also water is not effective. Why? Can you guys explain this to me?
What's that?
Anyone has idea? Why, if the cause of fire is a petrol, a diesel, or a kerosene oil, why water is not recommended to turn off the fire? This is not because of this reason. First thing is water is heavier than oil and petrol, right guys? So if you were to use water, what will happen? Water will not settle down near the oil. This is your oil, and the water will settle down the oil. So in that case, still there will be fire, right? So if you guys notice, if you guys notice, if a cloth is burned, okay, or let's say if someone pours petrol in swimming pool, okay, if someone pours petrol in swimming pool and tries to light it, the petrol will caught fire. Why? Because petrol is lighter than water and it floats above water. So if you use water to turn off fire, the water, since it is heavier and oil is lighter, oil will start to float above the water and water will be below it, right guys? Hence it is not recommended to use water to turn off fire if the cause is a liquid fuel, right guys? The next
Yes.
thing is cut off the air supply. Air supply. So most common thing used to cut off the air supply is either using sand. Okay, if a person or let's say in any object has caught fire, you spread sand over it. It will be covered in layer of sand, so there will be no access of air to the substance on fire. Next thing is fire extinguishers are used. See this. The role of the fire extinguisher is to cut off the supply of oxygen or bring down the temperature of the fuel, or both. In fact, it can bring down the temperature of the fuel also. Now, let's say I have taken a small chair here. Okay, and it is on fire. It is on fire here. And I need to um, cool it down. Okay. So what I will use? I will use fire extinguisher. So fire extinguisher will release carbon dioxide molecules in the air, right guys? So the thing about carbon dioxide gas is that it is what? It is denser than air. Remember here, CO2 is denser than air. So what this CO2 will do here? It will
That
form
it
a
also
blanket. Yeah.
the CO2 also absorbs heat.
It also absorbs heat. Very good point. Okay. So this CO2 will form this CO2 will form a blanket over the fire. Okay. And since it is denser than air, the lighter particles of air will be removed from here, right? They will be removed from here. Since CO2 is denser and it forms a blanket of gas over this fire. Hence, there will be no access of air to this fire. Right, guys? All the lighter
Yes.
gases particles around the fire will be removed because CO2 is denser and it is acting like a blanket and it enwraps the fire enwraps the fire. That's why the fire will turn off in this case. Okay, hope you guys got this one. Okay.
Yes.
So note one thing here, that this carbon dioxide gas neither burns itself. This gas, it itself does not gets burned, and neither it supports burning, right? Because oxygen is the gas known to support burning, and CO2 is not known to support burning, right, guys? So these were the three methods how you guys can turn off fire. Okay, and the interesting thing is that the chapter is not here. The chapter basically is finished here. Okay, here's it is about the fire extinguisher used in the room, in our home or in offices. So one should keep a fire extinguisher at home. Do you guys have one?
No.
Okay, okay. In fact, I'm planning to get it for my home. One should have it at home, right, guys? Okay.
Yes.
Any confusion to you guys in this chapter?
No.
Okay, okay. So Arhan, since you joined later in the later part of the chapter, so if you have any confusion, just do one reading of the chapter yourself. Okay, and revise whatever we discussed in today's class. If you have any confusion, we will discuss that in next class. Then, Ahmed, any confusion to you?
No,
Yes, Ahmed.
you know.
Okay, let's quickly discuss this question. List conditions under which combustion can take place. If there is availability of fuel,
In presence of friction.
presence of friction, very good. That means heat, fuel, heat, and what?
Air.
Air,
Oxygen.
exactly. Exactly. Burning of wood and coal causes
Pollution of air.
pollution. Very good. A liquid fuel used in homes